So here we are on lab 3 on the self-biasing saturation region of our NPN transistor. I'm just going to go ahead and highlight how we would go about choosing our RB, RC, and finding out what our IC needs to be. So we were given that, or I guess the transistor will turn on, so when it's saturated, it needs to have a base to emitter voltage of 0.7 volts. And we were going to go ahead and just go with the standard values of a VCC, so that's the supply voltage of 5 volts coming from here. And our VCE, we would say, is just a difference of 1 volts across the collector and emitter. And looking at the data sheet for the transistor to be in saturation, IC needs to be at a value of 10 milliamps. And for us to get a current gain of 200, this is a relationship that we would need to be using. And to kind of complete this relationship, you'd have IB is 200, and we already know that IC is equal to 10 milliamps. So by knowing this relationship, we can determine that IB has to be about 0.05 milliamps. And so that is solving one of our relationships. And looking back at the equations and just doing some voltage division, we can incorporate these two equations and rearrange them like so. This is how it starts out, and we can just find that by rearranging them we can get the difference between, and we can start isolating those resistance values. And so just plugging in everything we know, the VCC is going to be the same in both, and the collector to emitter voltage is going to be at 1, and our base to emitter voltage is at 0.7 to turn it on for saturation. And just by rearranging those variables there for RC and RB, we get that the collector resistor has to be at 400 ohms, and our resistor for the base has to be at 86K. And we already were able to find out what IB and IC were. Unfortunately, in the experiment, IC was refusing to be calculated in the correct magnitude. But I did notice, as I've explained in the lab report as well, it still produces a 2, but it's consistent throughout the future experiments that it remains to be off by a magnitude of 100. But we remain in the same realm of being at a current gain of 2. I'm not really too sure why this would be happening, but the fact that it's been consistent tells me that it's either something to do with the multimeter scaling it automatically, or if there's just something else that's going on, but it's been producing consistent results. So let me know if you want me to explain anything, and thank you.